What up, what up? It's been a while since I've streamed, but super excited about it. So, if you haven't met me before, my name's Tanner Lindsley. I stream occasionally on React stuff because I really like it. So, today I was planning on showing you guys some cool stuff with state. I know there's been a lot of talk on Twitter lately, like Kent C. Dodge just released a blog post about just using React to manage state. Redux today just announced they released hooks for state management. So there's like a lot happening in state right now. There's like it's been going on for a while already, but like I feel like there's like even more so now. There's like a good level of like renaissance happening, and people like going back to just using React, using the platform to build their applications. I am all about that. Libraries are great, and I know that I build some libraries, and they're like building a library to do something cool is great, but state management is something that is so critical to every application that I feel it's something that we need to be able to do right in the platform. So hopefully today I can show you guys a little bit about how that can work, probably go over some familiar concepts, and probably go over some new concepts that you haven't seen, and hopefully be able to answer any questions you guys have about how I do state management in my applications, and how I'm running that in production, and how to debug, and yeah, hopefully we can just like explore some really cool options of using just React to build state management. So let me jump over here to my desktop. Okay, so out of the gate, I'm going to assume that you guys know what hooks are. Sorry if you don't like hooks or don't know what they are yet, but hooks are React now. So there's no reason in not learning hooks, because like that, don't think of it as like a separate feature of React. They are React now. And we can start out with some simple state like we'll just do like an on switch. We can set on, and we can use state, which is a React hook that will help us manage some state without using classes. So we have this hello. We can render on to string right here. And then we could put a button right here that says toggle on click. And let's see, let's just go straight into this. We'll say set on, and we're going to do a toggle, so we'll do a function overload here, and we'll just say return the opposite. So, this needs to have closing right there. Okay, so this is what managing state is like in React at the component level. It's fantastic. It gets the job done. And we're going to see how we can expand on this idea where this is how everybody starts, right? Everybody puts a use state in their component or a use reducer in their component, and then they go from there. Things start to get complicated quickly when you start managing multiple parts of state across your app or needing to share state across your app. So if we had, let's say, a component called toggle, and it needed to know about this on state, then we would either have to pass the on to it as a prop, and also pass the set on to it, right? So that it can update it. And then if something inside of toggle also needed that, you can see how you start passing down props that you don't need. And this is called prop drilling. And there have been solutions to this. I'm going to quote Kent C. Dodds again here. There have been solutions to this from the very beginning of React. But a lot of people jumped to Redux to solve this problem. You don't need to do that. You never really did, and I know Redux made it easier to do this, to solve this problem. But you don't need to do that today. And I'm going to show you how you can use context to get around that too. So if we're just building out like a really basic application, we're going to need some use cases that are a little more serious than like a toggle. So I've prepared like a little to-do kind of sandbox here that we are going to experiment with. It's got some cool little features to help you guys understand what's going on. Like I have this little Flash. It's a Flash utility that basically flashes an element with red anytime that it updates. So you can see when I type in there, it flashes this. When I hit add, it will flash around there. When I click one of these buttons, it'll flash red around it. But this is just a skeleton of a little to-do app that we're going to build. And actually, I haven't even prepared a lot of this to-do app other than what you see here. So yeah, we'll get to see how I approach like building an application as well. Feel free to ask questions throughout. If it's a question that might get a long-winded answer, I might wait till the end to answer it. But for the most part, if you have questions about the code, I can walk you through it. So we're just rendering this application right here. So our index just looks like this: import app and render the app into our root. So here's our application, and we render a div with a filter bar at the top that's going to let us filter on the to-dos that we have in our to-do list. We have the to-do list itself right here, which is just rendering a list of to-dos with an edit button and a checkbox next to those. And I actually decided that for this example, we're not going to do the edit button. So it's just going to be this. So let's see, handle edit is not defined. Well, of course it's not. Okay, we'll just do this. So you're going to be able to check these to-dos on and off with this button. It's going to be really simple, right? But it's going to get the point across on how we can do some state management. So at the very beginning of all this, you can already tell that these things are going to need to share some state. Filter bar and to-dos and add to-do, they're probably all going to need to know about to-dos in general. And if we were just to like get outside of React for a second and look at what to-do states might look like, this is probably what they would look like if they were vanilla. Like, you're going to have an array of to-dos, right? They're going to be some objects with IDs, names, right? There's going to be like a done property to tell if it's done. That's why the flower's crossed off right now. And then you're just going to have a bunch of functions that help you manipulate these to-dos. Like this function, get pending to-dos, will actually take the to-dos and give you back the ones that are not done. This get done to-dos will give you back the ones that are done. Add to do is just a simple push function into the to-dos array, something that we can all understand, just pushes it into the bottom of the list there. Remove to-do by ID, takes an ID, filters the to-dos. Toggle to-do by ID, yeah. Like, these are all mutable actions. Clearly we could make these immutable as well if we were going to use something like a reducer, but I don't really want to get into that right now. We can also have like a rename to do by ID, but we're also not going to need that one. So how do we take this idea of these to-dos, this simple state management, these functions here, how do we translate that into React, building our own state management? So out of the gate, let's just start building this application and see where it gets us. So in our app, let's just, we're already importing to-dos right here from the store. So let's pass to-dos down to the to-dos component. So this to-dos component right here is going to get this to-dos prop. And then it's going to map over them and render an individual to-do. And we're passing every to-do the information that it needs. So here's the to-do component right here. It gets a name, done. Show strike, we'll use that in a little bit, so just ignore that. We're actually using that flash component so we can tell when it renders. Nothing's re-rendering right now when we like click any buttons or anything like that because we haven't wired it up yet. But you'll see here in a minute as we start wiring things up that some of these elements are going to start flashing red, which means they're re-rendering. You might be wondering why I keep talking about why, like, oh, it's going to re-render. Because re-rendering components can be a great thing, and it can also be a bad thing. It just depends on your use cases. So we're going to talk about the trade-offs of both having a state management system that purposefully causes renders and having one that doesn't. And they both come with their own challenges and their different trade-offs. So right now we need a way to filter this to-do. Let's just wire it up as if we weren't doing any global state management out of the gate. So right now we're bringing in the to-dos from the store, and let's just do this. We'll say To-dos is going to add to-do. And you know what? I actually feel better about, let's just not even think about this, this store in terms of this right now. Let's just bring it into the application, and we're just going to do it with hooks right inside of here. So we're going to have a list of to-dos. We're going to have set to-dos right here, and that's going to come from React use state. And we're going to seed it with these to-do items right here, okay? And so we have this set to-dos function. Let's just pass that set to-dos function down to our to-do list right here. So right here in this to-do list, it's going to get that set to-dos function we're passing down. Whoops. And then it's going to map over here each individual to-do, and this is a perfect example of what I'm talking about with prop drilling, right? If we would need to, like if we had a way to update this to-do, we'd have to pass down set to-dos to every individual to-do element so that it knows how to update. So when they click on this button, it's going to be a toggle. Let's wire this up. We'll say handle toggle. We'll make a new function here called const handle toggle, and we're not even going to handle the event. And what it's going to do when we click that is we're going to be calling this set to-dos function. That's coming from the props that we're passing down. And we're going to be calling set to-dos. We are going to need an ID from this to-do. So we're going to have an ID, a set to-dos, and the way that the normal React set state works is you can just take the old state and return the new one. So these are going to be the old to-dos. Let's do this. Old to-dos. We are going to need to do an immutable set state. And you know what? This is already a great opportunity to show you one way to solve this problem. So React set state, you know, in all the simple demos you see, everybody's just changing one key or changing some little things. But we're already in a scenario where we need to update the property on a nested element in an array. And that can actually be pretty hard to do if you're not familiar with immutable JavaScript. So there's a library out there called Immer.js. And Immer is awesome because you can basically perform mutable operations like push or just assign variables on certain things, and it will produce an immutable set state for you. And I don't want to get too into Immer, but I am going to use it here. So let's import Immer from Immer. And we'll add it as a dependency. And so right down here in this to-dos right here, we could take the old to-dos now and run them through Immer, right? Which is going to give us a draft that we can then manipulate however we want. So what we could do is we can now go find this to-do that we are editing right now. And we can say const to-do equals draft find, where the to-do ID equals the one that we're editing. And then we'll say to-do done equals not to-do done. Now that, let's see, it should be text decoration show strike through done. To-do does not equal done. So just to test this out, we're going to say const new state equals Immer console log new state. And we're going to log this out. So encounter two children with the same key. Oh, well that is because date now is not a very good random ID. We'll just do math.random times 1000 math seal. There's some better random IDs. Okay, the above error occurred in the to-dos component. So right here, when we clicked done, so it is giving us the new done when we click that first one. So the milk item is now done. And we are going to return that when we're going to return that new state right here. So I'm clicking it, but nothing's happening. If we inspect our object that we have here, so every time I'm clicking it, it is in fact performing that update. So is done true is going from true to false. But we're returning the new state here on set to dos. The question is, why isn't it updating our strike through? So if we come up here, so set to dos, right, is coming down through here. To dos is coming down through here. Let's just make sure that we're getting console log to dos. Let's just log out that first one and just see what we're getting. So it is coming through as true, false, right? And then, so it should be going through to the actual to do. So this should be, let's see, done. Oh, it's the show strike. Let's just get rid of that because that's a concept. We'll bring it in a little bit. Okay, so as we toggle these, you can see milk is toggling on and off. And eggs, great. So we are managing state, but with prop drilling, right? Let's set up the add to do really quick as well. I've already got some kind of boilerplate code here of managing this input. So when we type into this input, it's in a form, we can hit enter, and it will call this add to do button where we set the value to nothing. But before we do that, we want to add the to-do to the actual to-do list. So this is going to need the set to-dos function as well. So let's go up here and add that as well. Set to-dos equals set to-dos. Now add to-do can use set to-dos as well. And we can do the same thing here if we want. It gives us the old state, so it'll be old to-dos. Right? We can use Immer to, in fact, we don't even need to use Immer for this one. We can just return the old to-dos with the new to-do in there. So we'll make a new to-do. We'll give it, you know what, let's do this. We'll say const new to-do, or make to-do equals function that's going to return ID and to do. Cool. So now all of this can go away, and now this is just make to do. Okay, so now down here we can just use the same function to make a new to do. Make to do, and we're going to call the name whatever the value was. That will give us a new ID, so when I type in sugar, it should add sugar to our list, and we can toggle it on and off. Sweet. Now let's wire up the actual filters here. They're not really doing much right now. But we wanted to have a way so we can say, you know what, just show me my pending ones, or show me the ones that are done, or show me all of them. So we're going to need some separate state for that. So let's just do that right here. We'll say const, we'll say filter type, and we'll say set filter type equals react use state. And we're just going to use we'll just use strings for this. So we'll just start it at pending. Then we're going to need to send that filter type down to the filter bar. And then we're also going to need to send down the set filter type to, this might be really painful for you to watch if you just really cannot stand prop drilling. I'm doing this so we can I can help you better understand why prop drilling is a pain. And it will also help us understand like why we need to essentially build our own state management in React. So filter bar is now getting filter type and set filter type. So let's bring those in. Filter type, set filter type. Okay, and so now we can use those. I have this little filter thing here that takes a type that we can, let's see, we're going to need to pass down filter type to all of these. Actually, we'll just do active for now. So active will be filter type equals whatever, whatever this is. Oops. Type pending. Right. And then we'll just do on click. We'll just do the on click up here. Filter type, show type, on click, set show type. Okay. So this is going to be active now. That we don't have in there. And let's see, pending, active. So on here, we're going to have on click, which is going to call our set show type with whatever the type is that's in here. Oops. Pending. Okay. Set filter type is what it is. Okay. So let's see, it should be setting filter type to pending. So set filter type will come up to, let's see, filter bar. Set filter type should be calling set filter type here. So filter type should get sent back down through the filter bar. Filter type here. Active is filter type equals pending, done, or all. And then we're sending through the active, which should be yellow. So we're clicking on these, but why are they not updating to yellow? That is the question. So set filter type all. Set filter type is coming from use state. Set filter type. Filter type is coming back down. Active. Set filter type. Pending. Well, let's just console log out our filter type and see what's going on. So when we're clicking these buttons, nothing is happening. It's probably because the on click is actually not even getting fired on filter, because we need to spread the rest onto here. So let's do that. Okay. So flash type button, that's important to be on there. Rest. Okay. So you can see now we're clicking and we're getting the yellow for the one that we're on. That's great, but we're still prop drilling on some things. We're going to get rid of that here in a second. But one interesting thing you can see here is now that we have our state, we have lifted our state out of the filter bar and to-dos and add to-do, like all the state that we needed to share, we have lifted up out into the application state. And that's great. That's the way that you need to do state sharing in React. It's the same way you do component sharing. You're going to share a component, you lift it up. And now that we've lifted up that filter type state, we can actually put that into to-dos, and we can say filter type equals filter type. Now in our to-dos component, we can filter based on the filter type. So what we'll do here is we'll say const filtered to-dos, and then we're going to say filter type. If it equals pending, then we only want to do the, let's see, we want to take to-dos and filter them so that they're only showing ones where that aren't done. But then if we are doing filter type if filter type equals done, then we want to filter on the to-dos where they are done, right? Or we'll return the to-dos. I know we could use a switch statement for that, but that's okay. So now we are going to map over the filtered to-dos. So you can see as we check these off, they're now leaving. But if we come into done, these ones are done and we can bring them back out. Or we can do all and it will show them all. I mean, this is a basic to-do app, right? But this is already feeling pretty slick. So we can check them off our to-do list. We can add a new one, check it off, come back in here. You know what? Let's bring them all back. Hey, which ones do I have done? None, pending, sweet. So now that we have all this state and everything working, lift it up, right? This is fantastic, but look at something that's happening. You can see that as we're changing things, like as we check off one of those to-dos, even the pending done, all, even the filter bar is re-rendering, and the input box, like that doesn't need to happen. Now, let's talk about need to happen though. Does it need to happen or not? This is a difficult question because, in my opinion, you can get it really far in React by simply building your components, building your hooks and your logic to be re-rendered frequently. If you think about it, really performant React apps are probably re-rendering all the time, right? They're going to have scheduling in the next version of React to help with this constant rendering because the user wants constant feedback. I feel like it's a pre-optimization to assume that something needs to become manually re-rendered. And when I say manually re-rendered, I'm talking about using hard memoization on props. I'm talking about using any imperative means of updating that component or tying it to specific things. I personally like it when my components re-render, and especially with hooks, because hooks means that all of my effects and my state and all of these important things that hooks are doing are in the render function, which means running those render functions now becomes even a bigger priority for me. I would much rather use memoization, in fact, use memo inside of my components to make expensive operations faster or more performant, but always allow my components to re-render. Now, there are edge cases to that where you wouldn't want to do that. If you have thousands of elements on a page and they're all re-rendering for no reason at all, you might want to look into using memoization or any type of, it could be, let's see, use memo, or it could be react.memo, right? You could use either of those to do that. Like right now, this is re-rendering, but I don't think it's a problem. I want to show you how we can remedy this at the end of this live stream, how we can get rid of everything re-rendering all the time. But for now, let's just roll with it and see where we get. So we've hoisted all of this state up, right? And as far as I'm concerned right now, this is a working app. We could ship it and it would be just fine. But it does make managing things a little bit of a nightmare, especially with all of these, all this prop drilling happening. We're passing props through components that absolutely do not need them. So let's get rid of the prop drilling. And I think the only way to get rid of prop drilling is with context. So I'm going to show you how to use context right now. We are going to make a new context up here. Let's just call it to-do context. We're going to say React create context. And this gives us a context object here that we are going to bind to and pass down. So we're going to need to supply this context to basically our entire app right now, anything that needs this context. So we're going to say to-do context provider. So every context that we create gives us a provider that we can use to pass values down to children behind the scenes. You do that by passing a value prop right here. And whatever we put in that value prop is going to get passed down. But it's just like, it is exactly like a normal prop though. So if we pass down, say, math.random right here, every single time this component re-renders, we're going to get a new random number, and it's going to be pushed through this context provider. Well, anytime that this value changes with the context provider, it's going to try and re-render anything that's subscribing to that context, because this is a new thing. And similarly, if we were to pass down a new object every time with stuff in it, even if stuff was just foo bar and the foo bar was the same, but this is a new object every time that we're passing something down through this provider. So we're going to need a way to memoize whatever's going through there, so we're not triggering updates when the context value is never changing. So out of the gate, we know we're going to need to send down to-dos and filter type and set filter type and set to-dos. So why don't we start by doing that? Let's do context value right here for now. Context value equals, let's pass down to-dos, set to-dos, and filter type, and set filter type, and we're going to pass those down. And that means that we're not going to need to send through any of this stuff right here. So that cleans up quite a bit of our prop drilling problem there. And I did mention that this value should not change unless any of these things change. So let's use react.useMemo on this. And useMemo, it just takes a function, and that function executes whenever these dependencies change. And we're just going to use the same dependencies in here. Filter type, set filter type. So anytime any of these change, it's going to call this function, which returns a new object, and we'll get context value. But if these don't change, then context value will be the same object as it was last time. So that means we can safely pass it down through this provider, and it won't cause unnecessary re-renders in any subscriptions. So how do we use this context value? Well, let's go into the filter bar, the first component we have here. These filter type and set filter type, we were coming from props, but now they're going to come from React use context, and we're going to pass in the to-dos context. I think it's the to-do context. To-do context. So those values are coming from the context that we're sending through right here. And all that should work exactly the same. The filter doesn't need to change at all. The to-dos, so instead of getting these, we're going to want the to-dos, the set to-dos, and the filter type. And all of those were coming from props before. So you can see how they just kind of move into this context right here. Also, to do the add to do function down here was also getting set to dos from props. Well, let's move that down to come out of our context. So everything here should still be working exactly the same now, except for we're not prop drilling, and that's the best part about it, right? Now each of our components is subscribed to the store in a way that doesn't require us to pass them through all these components as props. This is fantastic. So what if we wanted to add some new stuff to this store, right, to this context value? Well, we'd probably end up building some more state right here, right? And then we'll pass it down through context too. And what we're going to end up with is a bunch of values and a bunch of setters and getters. Now, there's a couple of schools of thought here. one school of thought is that if we were to add more state to the to-do state, like the to-do scope, then putting it inside of this context would not be a bad thing at all. One way that we can kind of make this easier to grok is we can take all of this stuff and we can move it out into its own component. So we'll call this const todos provider. Function todos provider. And what it's going to do is just going to render this provider for us. But it's going to have the value in there from the get-go. So this to-do context, we're just going to call todos provider. And it's going to return children. And this children is going to be coming from the component. So now, anywhere we need a new to-dos state, right, we can use the to-dos provider and provide it down to any of these. This would make testing really easy because now, anytime we need to test a filter bar, a to-dos component, or an add to-do component, we just need the to-dos provider above it. And we could even add a way to mock the state in here too. Like if we wanted to say state equals something, and we could pass it through. There's a lot of different ways that we could go about testing this, but it does help, help us reuse this to-dos provider if we want. But what if we have other state that we need to worry about that doesn't have to do with to-dos? What if we had a user login, like where you needed to log in before you could actually see your to-dos, or there was like some settings or any other type of state, right? It doesn't technically have to do with to-dos. Would we make another provider here, and call it like settings provider, and we would have to provide that down to the rest of our app? Some people would say yes, like that's totally fine. Some people would say no, what you should do is you should use global state. In my opinion, they're both great at doing specific things. If you have two state slices that don't need to know about each other at all, I love the idea of making separate components, like different providers that use different contexts to manage all that state together. But in my experience, more often than not, you run into situations where you're either accessing a lot of data from both ends of it. You're accessing data from both to-dos and settings and users, and you're kind of like using them in the same place, or maybe you need to update them at the same time. This is the concept that Redux has made very normal for people, is keeping all of your state in a single object. Now, one of the downsides to that is that as your app grows in size, it means you're going to have a single provider above your entire application with all of your state. And anytime that state updates, that provider is going to update as well and push updates through the rest of your app. Every single component is going to re-render whether it's utilizing only a specific part of the state or not. So by splitting up your state into separate providers and only using those providers where you need them to, you are scoping your state and your state subscriptions so that only components that utilize that context update. I still want to show you how to go the global route because it will present the problem at the end where all the components will be updating when they don't need to, and I'd like to show you how we can get around that. So instead of this to-dos provider, let's just call this the store provider. And we're going to kind of make things a little bit more generic. So we're going to do store provider here. And this use state, this to-do stuff here is great. But what if we were just to add like something like initial state here? And we did to-dos, and we put those right there. You know what? Let's do this. Initial state. Okay. So the store provider is going to get an initial state here. And we're just going to pop that into this use state that we were doing right here. So this, instead of to-dos, just becomes our state, and this becomes set state. And all this filter type, set filter type stuff is just going to become an implementation detail within that state. So we have our to-dos. We're going to have filter type that's going to start off as pending. Right? And this context value, instead of infinitely growing with whatever values and setters we need, we get to become a little bit more generic here. So what we can do is we can pass down. I love the idea of passing down an array. If there's only two, like a getter and a setter, passing that down that way is really cool. So we're going to memoize and return state and set state. And anytime that state changes, we're going to rerun that function and give back this new array. So this context value is being passed down. So now that we're memoizing on this state, the context value is only going to update subscribers when they need to, when the state actually changes. So we're going to need to change the way we consume this state now. Instead of to-do context, really what this is store context. So everywhere that we were using to-do context now, we need to use the store context. But that also means that we're going to be getting back different values from that store context. So instead of getting back an object, what we're getting back now is the first piece of it is state, and the second piece of it is the setter. So this right here would be pieces of the state that we need, and we'll call this set store, just so we're not confusing it with local state. And we don't need set store in here. So we'll get rid of that. And then to do is going to need set to do's. I guess that's something that we didn't handle before. So we're going to come in here, and this is just our regular state that we're getting right here. And this is set store. We're not using the store, but we're going to use set store right here anyway. So set store is just going to take the old, and right here we're going to find the draft to-dos. So we want to find that and change it there, and then we're going to return the new state using Immer. And this is interesting that we're using Immer just on a piece of our state, that we don't have to use it on all of it. I'm going to show you a way here in a minute to take Immer and hoist it up into the store so that we can do this everywhere, which is really neat. So that should be working now. So let's see, set to-dos is no longer coming from that object. It's coming from, so here's the store and the set store. So this is set store, it takes old, and let's use Immer here again. Let's just return Immer old, which gives us a draft. And we're going to say draft to-dos push, and we're going to push on this make to do right here. Okay, so this is working again, except for our filter. So let's go check out why our filter isn't working. Let's see, filter is one that we didn't update yet. So filter type is coming from the state, and then this is just the set store now. And so set filter type is actually, let's just do this. Set filter type equals a new function that takes the type and sets the store, takes the old, and we'll just say returns the old with the filter type as the new type. Okay. So now if we ever need to add in extra stuff to our state, we can do that because we are sharing a global state object now. And also what we've done is moved away from setters, like individual set functions, into just using the set store function. we could make some utility hooks to do this. Maybe that's something I'll show you at the very end as well. I will think of what I'm going to coin that as at the end of this. I've been calling it action hooks, but at the end of the day, I think what they really are is just abstraction hooks. And I know abstraction is like an evil word right now, but I think you're really going to like them. So I said I was going to show you how to hoist Immer up into this store provider, because what if we just wanted to have Immer built into our stuff? So instead of this, having to use Immer every time in here, what if this just was the draft and we could get rid of that? That's what I would like. So let's just assume that that's going to be there. Set store. This is going to be a draft now, so we can just say draft filter type equals type. We can get rid of that. And set store. Okay, so we're just going to assume that we're using Immer everywhere. And how do we do that in our store? Well, we can say const, we can make a new set state. We'll do const Immer set state. And what it's going to do is it's going to take a function, well, really it will take the value. And we're going to say if type of value equals function, value equals Immer. We're going to take, oh, okay, and yeah, that's what we need to do. We need to use the old set state, the original set state in here. So we're going to return set state, which is going to give us the old value, and we're going to pass that old value in there and then pass our updater function if it's a function. But if we don't pass a function, we're just going to, well, actually we want to have it always be a function, I think. So set state old, we're going to pass, we're going to return Immer old updater. Yep, I think that's exactly what we want. So let's just old updater set state. This will just return that. So we got some currying here, and now Immer set state is now what we're going to pass down through here. And Immer set state will, let's see, that will get created every time the store updates, but that's okay. We're only updating context value when state changes. So now Immer is just built into our store now. You can see it wherever we're using set state in our app, or no, it's set store is what we're using. Anywhere we're using set store now, we're just using Immer out of the gate. So we just get a draft and we can do whatever we want. That, to me, is super powerful. And this is the other thing, it's like we're not using a state management library here. Immer is not a state management library. It's just an immutable utility. So that like you can bring in tools to help you build state management and make you more productive. So let's move on a little bit further. Let's say, let's see, what should we do next? We can add to-dos. We can check them off. So let's do this. I want to introduce you to the abstraction hooks pattern. So right now we have our store provider, and anywhere that we are using the store, we are subscribing to it directly with React use context and store context. I don't necessarily like that. I don't want my components to know about how my store works or where it lives to any extent. I like the idea of, and I don't like the idea of calling set store like something that can globally affect my store right from within my UI. So I want to abstract this stuff out a little bit, and maybe abstract is a bad word. Really what I want to do is proxy this stuff so that I can control it better and swap it out and iterate on it faster. So I'm going to create a custom hook here. And this custom hook is going to be called use to-dos. And use to-dos is going to supply everything we need to manage our to-dos right within this hook. So it's going to return to-dos. It's going to return the filter type. It's going to return the set filter type. It's going to return add to do. What else is it going to return? Yeah, a lot of that stuff. So we're going to go in and extract all of this data out of these components and put them in here. So what we have here is the store. And it's going to have the to-dos and the filter type in here, which are the only pieces of state that we're subscribing to. And then we have the set store function. And we're going to make this, we're going to pull all of these pieces out that were inside of here and replace them. So set filter type, instead of building it inside of here, is going to come from use to-dos. And let's see, instead of coming from here, it's going to come from use to-dos. And instead of this funky global store signature, it's just going to look like that. Same thing here, use to-dos. And instead of the store and set store, we don't want to be manipulating that stuff manually. So we're going to, like, what this is doing is toggling a to-do. Handle toggle, so set store. Really what we want is a toggle to do function that we can call. That is toggle to do ID. And we'll just call that down here. And this is going to become a toggle to do ID function that we get from use to dos. So let's bring that up here too. We'll say const toggle to do. It takes an ID and it's going to do that, and we need to supply that down here as well. And then right here, like, we're not going to get any of this stuff from there. We're just going to get add to do from from equals use to dos. And we're going to take this right here, this add to do, we're going to say handle add to do, add to do. This right here is going to be the add to do part that we take out. So it'll be add to do, and the only thing we're going to be able to pass that is going to be the name, so the value. Handle submit is also going to call handle add to do. Okay, so we have our local state, and then we're bringing in add to do. So we need to add the add to do up here. Which is going to take a name. It's going to create a new to do for us, just like that. So you can see now in our UI components down here, we are not fiddling with the store at all. We're not subscribing directly to the store. We're not calling set store or anything like that. This, I used to call it the action hooks pattern because it felt like you were building Redux actions through hooks. But really what you're doing is you're subscribing to values and you're getting methods. Really, you're getting everything you need in your UI as an implementation detail. You don't necessarily need to know how use to do is getting you these utilities. You just need to know that it can and that it has everything you need to be productive. And then we can leave it to the use to do's hook, custom hook, to implement that however we want. So at this point, if we wanted to switch this out for local state, or if we wanted to actually use Redux and pass through whatever, it's fine as long as we are satisfying this API that we have built for our UI components. We can implement that however we want. And you might also say, well, what about memoization? How is all this stuff safe, right? Well, to-dos is going to be the same object all the time unless it changes. Same with filter type. But what about these functions? We might want to use React use callback here to make sure that these functions are not changing. Callback type. Yeah, we want to make sure that these functions aren't changing unless they absolutely have to. And luckily this, like this set filter type, all it really relies on is the set store. And set store is only going to change when it needs to as well. Also, the toggle to do is the same, so React use callback is another memoization hook for functions. So const equals React callback. And then this one also only depends on set store. And then also here, React use callback also only depends on the set store. So now we can safely use these functions in memoization and callbacks and dependencies. Filter type is not defined. Where is that coming from? Oh, right here. We need to get the filter type from that as well. Okay. So now anywhere that we need to use to-do logic in our app, we can just call the use to-do's custom hook, and it will give us everything that we need to be productive with to-dos. And likewise, if we had a users, like if we had a users or a settings thing, like if we wanted to get the username, we could have another custom hook called use user, right? And underneath the hood, use user could be whatever we want it to be. It doesn't necessarily need to use this the same global state it's using here. It could use anything else. It becomes an implementation detail. So that is the abstraction hooks pattern. What it does is it allows all of our UI components to be unaware of the implementation of state underneath, or state, or really anything that doesn't concern them in the application. Let's see, we could organize this, and I could show you just exactly how small this is, but you could put this in a separate file and import use to dos and use it in a bunch of places or have multiple instances of it. What I want to show you next is how we might be able to play with our store a little bit to do some interesting things. So right now when when we toggle this stuff on and off, it's always re-rendering everything, and that kind of bugs me. Well, okay, it just bugs me for this example. So, oh, I see what's happening here. We have a bug. When we are adding a to-do, we're taking draft to-dos and we're pushing make to-do. Draft to-dos. Let's see, when we add Tanner, it's adding 2. Well, why is it adding 2? Add to do. Are we calling it twice? I think that's the most naive solution we're doing here. Handle add to do. Handle submit add to do. Handle add to do, add to do. We're just calling it once, right? Button on click. Actually, this shouldn't be on click right there. This should be type equals submit. And our handle submit should be the only thing that is doing this right here. Add to do. There we go. It's a little bit of UI bug there. Okay, so I want to show you how we might be able to alleviate. It's like what's happening now is anytime we're updating anything, the context store provider up here, not only is it sending through a new value, but it's also like we are updating the state on it. So store provider itself is re-rendering and causing a re-render in its children as well. So what we need to do is, at this point, honestly, I wouldn't care that all this stuff's re-rendering because it's super cheap, and we could probably re-render this at the speed of request animation frame, and it would be just fine. It would be really fast. And that's how I like to build my apps. I like to build them so that they're resilient to rendering. So I should be able to re-render my app a whole bunch and not run into performance problems. And the best way to do that is using memoization. We don't have any expensive operations happening in here, but if we did have an expensive operation, like if we were pre-computing the filtered to-dos and stuff, which we actually can do, that would be a great example. So let's just assume that we're going to get filtered to-dos from the use to-dos hook right here. Filtered to-dos. What did I just do? I'm not sure what just happened. So filtered to-dos, cannot read property map of undefined. Oh, it's a runtime problem. So we're expecting to get filtered to-dos right here. And we need to, so this is kind of like a computed variable or a selector in like in Redux. So if you're not familiar with a selector, it's basically a computed state that should only compute when things change. So when its dependencies change. So we're going to say const filter to-dos equals this stuff, but we don't want to be recomputing this, like refiltering this every single time it renders, right? That means every single time anything changes in the store, we are re-rendering. We are rerunning this logic right here. So what we can do is say React use memo, and it takes a function, and it will return we'll get the new value when these dependencies change right here. And the dependencies of this function, so are filter type and to-dos. So filter type and to-dos, whenever the filter type or the to-dos change, filter to-dos is going to run. And we can actually look at this if we say, if we log out filtering and reload, it'll say filter type, filtering. Oh, I see. So this is happening per instance. So everywhere that we're using use to-dos, so let's see, we're using it 1, 2, 3, 4 times, right? And then we are, let's see, each of those 4 times we're calling this filtering. But if we were to clear the console right here, and if we were to check off a to-do, it's going to trigger everything to rerun this logic right here. So if we clear it again and we change the filter type, it's also going to rerun this filtering for everything that's using these to-dos. And let's clear it one more time. You can see that as we're typing, you know, in this local state, none of that's technically changing. And it's just going to keep reusing the old filtered to-dos. And there is a solution to where filtered to-dos would not need to be recalculated for every single usage of used to-dos, and maybe we'll get into that in a bit. So right now we still are re-rendering everything that when it doesn't need to be re-rendered. This is really the exciting part. You know, this is the ending to my live stream where I want to talk to you about how you still can build a very robust state management system in React that can rival the performance of Redux if you want it to. So with Redux, what's happening is they're using subscriptions instead of, well, they maybe in the new version, but they should be using subscriptions in the context instead of actually passing the context down. Because you can imagine, as we're seeing here, when one little thing updates, everything has to re-render, and that stinks. So like even when we're checking off, you know, this milk, eggs, flour, whatever, everything is re-rendering and it really shouldn't. So how can we get around that? Well, one way is to use subscriptions. So what we want to do is we want to pass down a way for components to subscribe to our store. Now, disclaimer here is that I have not practiced this, and this is totally theory. So we are venturing into uncharted waters here. Get rid of my doc. Somebody said bigger font size. I got you. Okay, so what we want is, let's look at how we want our API to look and feel first. So in this use to-dos thing right here, let's say instead of React use context, we're going to say use store. And in that store, we care about 2 things, to-dos and filter type. So what if we could return what if we could do this? We could say store. What we want from the store is to-dos and filter type. Or what we really care about is just like we can select state from the store really easy. What we care about is keeping that state up to date without triggering re-renders. So what if we were just able to pass in some, like a function that takes some dependencies? So we could say like state.todos and state.filter type. could get really interesting. So let's make a new function called useStore, and we're just going to call this like get dependencies. Wow, I'm really flying by the seat of my pants here, but this could get really cool. So what happens here is we're just returning to-dos filter type. We're just returning the dependencies that we want from the store that will trigger an update here. Let's see what's happening here. Use to-dos. So runtime undefined is not iterable. So useStore is going to need to return. We'll have it return the store still. And we'll have it return, let's see, set context. No, set context. This is interesting. So, well, there's so many ways that we could do this. I'm wondering if the best way to do this would just be to kind of go at it as if we were like building our own Redux. So that's interesting. I wonder, say React Redux. If we change to next, alpha 1 documentations. Here we go, next. So there's some hook providers in here. Let's see how React Redux does it. So they have a selector, use selector, and it takes the selector and the deps. So, and then whatever you get back from the selector is what you get back from the result. Seems like a lot of double defining though, to be honest. I still think that we could do a better job on our own. So, what if we could just destructure whatever we want from the store? But to make sure that it was staying up to date, we had to supply the dependencies right here. So what we're going to do is this is going to use we're going to get the store and set store equals React use context and store context. And then what we need to make sure is that this context value is just never really updating. So we're going to just memoize it one time, and we're going to let's see, we'll do this. We're just going to pass actually let's use callback. And we're going to pass subscribe. Subscribe is going to be a function that takes a callback and we're going to add it to a subscriptions. Oh my goodness. Push callback. Then we're going to return a function that will remove it from subscriptions. Subscriptions equals subscriptions filter. Okay, so where is subscriptions coming from? Well, let's just do a ref. So we'll say const subscriptions equals React use ref. Let's call that subscriptions ref. And it's going to start out just as an array. And then Immer set state. So let's see, we got to think about this. So the context value is never going to change, but the context value is going to be a subscriber function. So we can use to add a callback. So we'll have a list of callbacks now, subscriptions ref. So somewhere along the line, we're going to have the subscriptions ref, and we're going to loop over them, and we're going to call the function with the latest store value. So it's going to be state. And you know, use state, this is going to trigger re-renders as well. So I think one way that we're going to have to do this is use a ref here. So it'll be use ref and it'll take the initial state. And then the Immer set state, what it's going to do is we're going to call Immer with the state ref current and the updater. And state ref current is going to equal the new one, Immer set state. And so the subscriptions ref is using that. Immer set state. So this is going to give us the state and the set state. In fact, let's just, we'll do state and set state, or store and set store. So the store is going to be, store is the state ref current, and set store is the Immer set state. So when someone calls the Immer set state, it's going to take the updater, run it through the current state ref, run the updater. It's going to do the state ref current, and then we're going to want to call, we're going to want to do this subscriptions ref right here. And let's see, this is going to, we'll say fire update. Oh, that was okay. Kind of a chicken and the egg problem here. So instead of fire update, we'll just do it right here. Move this up here. Fire update will take our, let's see, payload, fire update. Okay, I'll take the Immer set state. Immer set state will never need to change, actually. So what we're actually going to do is the context value is going to use memo as we thought. It's going to pass through the subscribe and the, we'll just call it dispatch because that's basically what it is. So subscribe is going to take a callback. Dispatch is this. You can dispatch an updater, and then we'll fire an update with the latest store. Firing an update will take the payload and send it out to all the subscriptions And let's see. We'll go. No, we don't want it to be. I know this is complaining right here that we aren't using that dependency, but we don't want to. We don't want to put that in there because we don't want this context value updating to trigger anything. We're just using it to pass it down. So we can take this subscribe function, adds it to the subscriptions. It's going to fire after we dispatch. And that should be all we need. So down here in the use context now, what we're getting now is a subscribe function and a dispatch function. And what we're going to do is say React use effect and when the component mounts, we're going to subscribe to the store with a callback. And that callback is going to give us the latest state. And we're going to take that latest state. We're going to be running that latest state through our selector. So let's see, use effect only when it mounts. We're returning unsubscribe. Dispatch, we're just sending through. And then let's see, subscribe. So when I relate a state, the one thing that I'm worrying about right here is the initial state that comes through state ref current is not getting passed down through the new state. So let's see, subscribe, callback, return, just callback. Because we're going to need it synchronously. So we'll just do state here, just kind of making this up as I go. So state is going to be the store ref current, I think. State ref current. And then, so this is going to be the state. And what we're going to do here is we'll say, we want to return only the piece. Well, we want to return the entire state. That's what we want to do. But we are only going to update this function when the get dependencies returns things that have changed. So what we need to do is actually, it's not going to pass through the latest state. That's not what it's going to do, because that would mean there's two different ways to do it. So instead of pushing the callback down or calling it with this payload, we're just going to call the fire update. And we're not going to call the fire update with anything, because we're just going to say, we're going to call state ref current, fire the update, and then state ref current, we're just going to pass through the state ref, actually. And that means that this is going to be the state ref. So we want this component to update when the get dependencies changes. So what we're going to do is turn subscribe, say const. Let's see, I wish we could just use I wish we could just use the memoization or like an effect here. But we can't because the use store technically won't render because we're using a subscription. So we're going to have to use like a deps ref equals React. We're going to have to make our own custom change detection here. So when the subscribe comes through, we're going to be taking use ref, and the initial thing it's going to do is going to be get deps, and we're going to call that with the state ref current. So that's going to initialize our deps ref, our dependencies reference with the function that we call it and the current state as soon as it initializes. But anytime that this subscribe gets called, we're going to want to say const new deps equals get deps off of the state ref current. And then we'll say if new deps sum dep return if the dep does not equal index. If the new dep does not equal the deps ref current index. If the new dep does not equal the old one, or if any of them don't equal the old one, then we want to call and set a set state right here. Or we'll just say update. So now we have this update function that basically what it's going to do is going to be like set count old plus 1. Now we do this because there's no force update with hooks. So we're going to force it to update by using React state. So we're going to have a count and a set count here from React use state. We're going to start it at 0. When we need to update, we're going to set the count to something higher, and that's going to trigger an update. So let's see, all we can check off this stuff now. Let's see, eggs, working flour. Can we add? We can add. If we go to pending, we're good. If we go to done, pending all. Okay, so we have this callback system now that's letting us bypass this stuff, but it still looks like everything is re-rendering. We need to make this better. So what we're going to do is we're going to say we're going to split this up so that we can get some better performance out of it. So the first thing we're going to do is make a const use filtered, or no. So use to do's, we're not going to have it, let's see, use to do's is returning on everything. The filter bar does not need the filters. So the only thing that filter bar needs is set filter type and filter type. So set filter type and filter type. We'll do this. Function use filter type. And we'll just say, we'll just return an array, and this is going to have set filter type as the second parameter, and the first one is going to be filter type. We are going to need to get those from, so let's see, set store, so use filter type. It's going to come from here, so we don't need the to-dos in this one now, and that means we don't need to memoize on those. We just want to memoize on the filter type. So whenever the filter type changes, we're going to get an update, and that means on this filter bar we can just say use filter type, and we'll get this. Set filter type is not defined. Right, because we're not passing that down. So now when we update these to-dos, you'll see that, let's see, I might need to re-render here. So as we were toggling those off, the filter bar was not updating. But for some reason it is here. Not sure why the filter type would be changing there. Filter type. So let's keep going. We have use to-dos, toggle to-do, and add to-do. Anytime the to-dos change, we don't need to necessarily do any add to-do stuff. So let's see, to-dos, filter type. So when the filter type changes, we are going to need to update our to-dos. And we'll need to be able to toggle to do and add to do. So you can see how there's, in a few of these situations, like, yeah, we're adding a new to-do here. It's not re-rendering this filter bar because we're starting to split our state up with these selectors. You know, and this is all uncharted territory for me, as you know, from the trying to create this performant Redux thing forward. I think the best thing that I've learned doing this with you today is that building a subscriptions-based state management system is really difficult. You start to have to bypass things that you would just do with React using normal React-y things. Like you have to start using refs. You know, subscriptions start to allow components to update at different times instead of following like a top-down flow. We're starting to get like little bugs here that I'm not sure where they're coming from. Where if we're in all, or if we're, let's see, pending isn't updating, like, yeah, let's see, maybe there's a bug actually that I just found that we'll get rid of that. So use filter type, set filter type. Set filter types going through. So, I don't know, it's not moving to pending. I just think, you know, out of the gate, building your own thing to match Redux is probably going to be like a difficult. If you're trying to build your own Redux, you might as well just use Redux. But in my opinion, we don't need any of this stuff. I think basically what I have come to realize is that I would rather build my application so that rendering is not a big deal, so that I'm just using memoization and using use memo for, you know, complex tasks inside of components, and using use memo to memoize the output of a component too. Like, that makes it so you can have reliable render functions that get run when you need them to, so side effects can happen and whatnot. And then you don't have to start doing funky things that, you know, start building your own Redux. So if I could go back, I would probably just get rid of all this and go back to our little use state solution where we're using just Immer and we're passing it down through context, and it's fine that everything re-renders, in my opinion. I don't like to pre-optimize. In Nozzle right now, I'm using this approach, or I'm using not this approach, but I'm using just the context approach with a single global store. And Nozzle is extremely performant still. I haven't run into any bottlenecks yet, and I feel like all my components behave more reliably since I'm able to have them update and run their side effects and their state and all their render functions when I need them to. Yeah, so I don't know if you guys had any questions about this. I think this is a really interesting take on this. I think what I'm going to do here really quick, if you guys have any questions, I'm going to app.reduxe. I'm just going to copy this over into this Redux file, but I'd like to go back really to what we had, just so I can show you guys one more time that, using a single global state object with just context is totally fine. So yeah, go ahead and sorry, I'm just looking at some things here. Yeah, just looking at all this subscription code that we added in here to get around all that rendering problem, it just seems brittle. Seems like it would break. It seems like it'd be hard to test. Using React, just using the platform itself, instead of trying to fight the platform, I think is the way to go. So let's see. Oh, did we go past it? I think we went past it. Let's see. Let's go back. Use memo. Filtering. Yep, right here is where we started doing it. So, boom, right there. Using context. So, in my opinion, this is the way to go. It's reliable. It's fast. We could probably do it with a lot of components. Anyways, it was a lot of fun. Let's see. I want to make sure that I covered everything. Let's see. My tweet, I said I was going to show you guys how to said I was going to show you usage options. Going to show you how to use usage stuff, how to build your own store, Immer, show you guys how to do memoization, show you the abstraction hooks pattern, showed you how to use context, different ways to update. You can write to the store globally if you want, or you can use abstraction hooks, which is what I do. Showed you how to attack some performance problems. Yeah, I think that's it. So thanks for listening, you guys. This was a longer live stream, but that's what state management takes sometimes. It's a really difficult problem that, in my opinion, should not exist still in the React community. But for some reason, everybody has a different way of doing it. Hopefully, we can all come a little closer to just using React for state management. I think we'll get a lot better mind share that way. Yeah, so thanks for listening. Take it easy.